Hello viewers, my name is Damilare. In this lesson, we'll be looking at the topic tin. Tin is a common element in group 4. That means the group where carbon belongs to. Tin metal does not occur naturally. It occurs as the ore cassiterite. That means you always see it with another element. Cassiterite is tin 4 oxide, SnO2. Cassiterite, so that's your tin. And this tin 4 oxide cassiterite, we see it in gravels and alluvial deposits. That means those areas where you have water. That's where you can get all these tin materials. How do we extract tin? Since tin exists as tannum 4 oxide, tannum is the Latin name of tin. Tannum, Sn, tin. So that's the symbol of tin is Sn. So tannum 4 oxide. That's how tin exists. And tin contains a lot of foreign matter like sand, soil, sulfur, carbon, oil, like impurities that come with tin. Now, how do we now extract this tin? There's something we call flotation. What will float? What is the thing that will be floating? Take the ore of tin, that's cassiterite, you crush it, that's break it. Let it be shaken in oily water. That means water that has oil. Let it be poured there. What will happen? The foreign matter such as sand, soil, all of them will drown. They will go down because they are heavy. So while the tin, it will stick to the oil and it will float so that you can collect your tin. So that's what we call flotation. So this is the furnace where the cassiterite will be melted, where the process will take place. Now, how does it take place? Your tin ore, which is cassiterite, you pass it here. So that's your SnO2. Your coke, which is carbon, will also enter here. Why? That's the reducing agent, the one that is going to pick up any oxygen in the chamber or in the furnace. Limestone will also be added because the CO2 is needed. So the CO2 will heat the furnace the more through exothermic reaction, the CO2 that is there. So then the CaO from the limestone, so it will pick up any kind of impurities like the silica, yes, so that it can form a slag. So that is what the limestone will do. And any wastes that is now coming out in form of gas, they'll be passing this place. So it means the coke, the carbon, can pick up some oxygen and take it out as a waste. Now let's see how it operates. Here we have our tin ore, that's the cassiterite and the carbon that is coming together with the limestone. These three things are the major things we have. Then the hot air oxygen is one that will be burning the solution. Then from here, this is where slag will be coming out. That means anything waste materials, they come out from here. While the remaining tin, it will come down from this particular place. So this iron that is here is actually a mistake, so it should be tin, so it will be collected there. Tin ore is then collected and roasted to take away foreign matter such as carbon. So carbon is foreign, sulfur is foreign, oil is foreign. So those carbon, they go out in form of gas when it's added to oxygen. Sulfur also goes out in form of gas when it goes with oxygen. Lastly, the tin ore is mixed with carbon in the form of charcoal and is heated in a blast furnace at a high temperature. So the tannum 4 oxide, the one I call cassiterite in the ore, so it's always being reduced. That means the oxygen will be taken out from it, so it means it will be reduced to ordinary what? Ordinary tin by the reducing agent carbon. So that's the essence of the carbon that is coming into that furnace to pick up the oxygen so that it can reduce it to tin. Now, and by the time the carbon picks oxygen, the carbon will form carbon monoxide, that's CO, which is a powerful reducing agent that can remove more oxygen. So it has the ability of removing more oxygen from the tin oxide. So as you can see it here, this is the carbon picking the oxygen to form carbon monoxide. So the carbon monoxide can still take more oxygen from tin oxide so that it can form carbon 4 oxide, and the tin will now be alone. Then number 6, the melted tin that is formed collects at the base of the furnace and then is channeled out into a mold to form tin ingots. So that tin which we have finally gotten as a result of reduction, you can now pour it into a mold so that it can form any shape of your tin. What are the properties of a tin? The color is white, lustrous, shining. That's when you paint it, will be shiny. It exists in 3 allotropic forms. Allotropes means when you are forming different shapes using the same compound. So it exists in 3 allotropic forms, and they have different densities. How will you remember the gray, the rhombic, the white? So that's GROW. G for gray tin, rhombic tin, white tin, GROW. So and based on their density, that's 5, 6, 7. This one 5.76, 6.67.2. That's 5, 6, 7. So that's their respective densities. In terms of melting points, so it doesn't have high melting point like that. It can melt at 230 degrees centigrade, but the boiling point is very high. Before it boils, it will reach 2270. It's a good conductor of heat and electricity, so it can pass through tin. It's malleable, you can hammer tin. It's not ductile enough. That means if you say you want to draw it to wire, it may not give you what you expect or what you expected. Now, chemical properties of tin mean that when you add tin with some chemical elements or substance, what will happen? So you can add it with oxygen. So when you add your tin with oxygen, so what will happen? Remember that tin is unreactive. So tin being unreactive only combines with what? Oxygen. So it doesn't combine with most substances, but it can combine with oxygen above 1200 Celsius to form tin 4 oxide. So you can see the reaction here. Then it can also react with acid, that same thing, but it will be very slow. So it reacts slowly with dilute acid. But if you use hot concentrated acid, then it can react vigorously. So that's how it operates. And it can also liberate sulfur 4 oxide when it reacts with this H2SO4. So whereby the tin will join with the sulfate, that's tin sulfate, then the remaining sulfate will break into sulfur 4 oxide, and then the water will take the remaining position. Now reaction with alkalis, that's base, means that tin can still react with a base. So just take hot sodium hydroxide, hot one. So by the time you take hot sodium hydroxide, add it with your tin. So the tin and the sodium can give you sodium and tin. Then you take part of the oxygen here, the second oxygen, take it with hydrogen to form water. So mean that the water is from here, then the sodium and the tin and the oxygen will be sodium, the stannate, trioxostannate. So this is sodium here, this is trioxostannate. So that is how it reacts with a base. Then it can react with non-metals. Tin can combine with non-metal like chlorine. When you heat it, it will give you tin 4 chloride, as you can see here, tin 4 chloride. So that is the reaction. Now use this. What can we use tin to make? So the first, it is widely used to coat iron. So if you have iron, just surround it with tin so that it will not corrode, so that you can use it for your can. You want to store food, so that you can use it for the storage. You can also use tin to make alloy, such as bronze. Remember, bronze is copper and zinc, while soda is tin and lead. So mean that you can use it to make soda, tin and lead, or use it for bronze, copper and tin. So that's the usefulness of tin. So thanks for listening.